Let's have a look at the example how a confidence interval can be constructed for a population mean given we've got a small sample. So consider the company that desires an estimate of the mean increase in blood pressure of patients who take a new drug. And they take a group of 6 patients for the human testing phase. They find that the mean increase in blood pressure for this sample is 2.28 and standard deviation is 0.95. And the task is to construct a 95% confidence interval for the mean increase in blood pressure associated with the new drug for all patients in the population. So from this description, we can get the following information. The sample size is 6 patients, the sample mean is 2.28, and we know sample standard deviation, which is 0.95. We are asked to construct a 95% confidence interval, which means that the significance level will be 100 minus 95, which is 5% or 0.05. And since this is a small sample, we no longer can use z-score. What we should use is a t-value. So in this case, we need a t-value for 0.025. So 2.5% and for 5 degrees of freedom. So if we go back to our table with the critical values, so we see that we've got 5 degrees of freedom, 6 minus 1, and we need the t and the significance level is 5 divided by 2, so 2.5. So we move to the right and we get that the critical value is 2.571. So 2.571. When we substitute everything into the equation, so this is the case when we do not know the population standard deviation, so we know sample standard deviation, we get the following boundary. So the lower boundary is 1.283 and the upper boundary is 3.277. So we conclude that the probability that the true population mean increase in blood pressure lies between 1.283 and 3.277 is 95%. Or we can say that we can be 95% confident that the true mean increase in blood pressure lies between 1.283 and 3.277.